Good morning.
Good morning.
So, hope you all had a good weekend. Getting ready for the big push here at the end. So let's see, we've got all right, looks like we've got Holbrook. Who's missing in Winslow?
Diana and Andrew.
All right, thank you. All right, so let's see. Is Caden there? Oh, there's Caden. Okay. Okay, so today we're going to just go over questions. Hopefully you've had a chance to look at the practice final, or if there's anything else from the book or notes or anything that you'd like me to review. Let's see, what else? Okay, so just a reminder that for the next 3 days, you'll have part 1, part 2, and part 3 of the final. 20 questions each day. You'll have an hour. And then if there's any problems or anything with technology or anything at all, then what you need to do is talk to your lab aide, the talent aide, and say, okay, if you get sick or something, then you need to figure out another time that you can take it. But Thursday midnight, all 3 parts have to be done. So whatever's not done will just be a 0. So Thursday midnight, everything is in concrete. Okay? But up until then, work with your talent aides and have them email me if there's any problem, or text me or call me or whatever if there's an issue. Okay? All right. So beyond that, anyone have any questions, comments, concerns about the final?
For the evaluation essay, so is it going to
Yes.
be 5% extra credit or 5 points extra credit?
It'll be 5 points that will be added to your final exam after the curve.
Oh, okay.
Okay? So there'll still be a curve, and then if you do the essay, then I just check my inbox, and everyone that sent me something, I'll add 5 points to your score. And so then I enter that in with the curve manually, because I figure I've got to do if I'm going to do a curve, I've got to do that manually anyway to change the middle score. And then so I'm going to be doing all that on Friday morning. Okay, so yeah, so the essay also has to be done Thursday midnight. Okay. All right. Other questions about that or your grade or anything like that? Okay. Well, let's go ahead and go over any questions that you might have. So if you want to say number 37 on the practice final, or if you want to give me a page number and a problem, or however you want to do it. However you want to ask questions is fine with me.
So, can we go over 29 through 31 on the practice test?
Sure. Okay. Okay, there we go. All right, so for 29, we have y equals e to the x cosine x. So this is the practice final that's posted on the final section on the Moodle. Okay, although I do want to point this out is that a student who had worked through the thing said, Mr. Strong, you realize that there's no polar questions on there. And so anyway, I'm pretty sure there's polar questions on the final. So you might want to make a note of that, or if you want to ask me about polar questions. So anyway, so let's go to this. It says, what is the damping factor? So if you have y equals e to the x cosine x, the damping factor is the function in front of the trig function. So it's just y equals e to the x. That the e to the x part is the damping factor. So so whatever's in front of the trig function is the damping factor. All right, so it says sketch the graph of the function and plus or minus the damping factor in one window. Okay, so that would look like, well, this is kind of how it shows up in my initial window on the calculator, but it kind of looks like that. And so to get that, the functions that you put in the calculator are, so y1, you just put in the function, y1 equals e to the x cosine x. And then for the y2, you do the damping factor, e to the x. And then for the y3, it's negative e to the x. So that's what it means by plus or minus the damping factor, which was e to the x. So you do plus or minus that. And so what that does is it gets you the boundaries. Okay? And so the e to the x won't cross that. And then the last thing, it says complete this statement. So as x approaches infinity, so as the x value gets bigger and bigger, what does the y value do? Well, it's bouncing back up and down, okay? And so the y doesn't approach just one number, it actually approaches both positive and negative infinity because it's bouncing up and down. All right. So is that okay? All right. Any questions on that? All right. How about another question?
Can we go over some stuff on the conic sections from chapter 9?
Sure. So is there stuff from the practice final, or do you want me to go in the book, or what would you like me to do?
I don't really know. I just kind of missed a lot of the notes for like that chapter, so I don't really have a lot of that stuff.
Okay. Well,
Can we
one
just
thing.
go over like,
Yeah, one thing that I would highly recommend that you do there is just watch the videos, because we do go over the notes. But why don't we, if there's not a specific problem from the practice final, why don't we look at the chapter 9, maybe the chapter 9 book test, or the review. So maybe like 771 through 777. You want to just look over that and just, pick a problem, and we can just go through as many problems as you like, but let's just, pick one problem maybe at a time.
you said from 776?
Yeah, 771 starts the chapter review, and then 776 starts the chapter test in the book. So I would say something in there.
Can we do 1 and 2 on 776?
Absolutely. Okay. Okay. All right, so it says find the center, the foci, and the vertices of the ellipse that each equation describes. Okay, so for this one, it's already in standard form. And so then to pull out first the center, you take the opposite of these numbers in here. So the center is going to be at 2, -1. Okay, so that's the center. So to find C, the distance to the foci, you use the formula a squared minus b squared equals c squared for the ellipse. So that's going to be 81 minus 16 is 65. So then C is the square root of 65. It's a vertical ellipse because the number underneath the y is bigger. So that means we're going to add and subtract. Matter of fact, let's go ahead and put plus or minus here, because we're going to add and subtract C to the y value of the center. So that means we don't change the x value; it's still 2. But then -1, we're going to do plus or minus the C. So to the foci, you'll go up and down whatever that C amount is. Okay. All right. So let's see. So we've got the center, the foci. Okay. So the vertices, the major vertices are this number is bigger, so that means it's a vertical ellipse. So from the center point, we're going to go up and down 9, which is the square root of 81. So again, we start at 2, -1, the center point, but we're going to go up and down the square root of 81, which is 9. So that would be -1 plus 9 is 8, -2 minus 9 is -10. So our vertices are at 2, 8, and 2, -10. All right. So is that one okay, Toby?
Yeah.
Okay. So let's go on to number 2. Does anyone have any questions on this first one here? Okay. All right. So going on to number 2. All right. So with number 2, here let's write down the original problem here. We have x squared plus 4y squared plus 6x minus 8y plus 4 equals 0. And so before we can do all that business with the foci and the vertices and the center and all that, we need to put this in standard form. All right, so the first thing we do is we got to complete the square for both the x's and the y's. So I group the x's together and I group the y's together, and then the 4, the constant, just move that to the other side, just to get it out of the way. All right, now, I have a number in front of the y squared, so I need to factor that out. So factor of 4, and then I'll have y squared minus 2y. All right, now I'm ready to complete the square. So what do I add in the first one to complete the square?
Will it be 16? Or, I mean, not 16, 9.
9. And then the second one?
1.
1. Okay? So I add a 9 in here, half the middle term squared. So if I add a 9 here, I've got to add a 9 over there. And then I'm going to have this middle term, negative 1 squared is positive 1. But see, since I actually factored out a 4, I've got to add a 4 over here. Okay? And so now I say, okay, this is a perfect square, x plus 3. This is a perfect square of y minus 1. Over here, the 4's cancel, and I just get 9. So I've almost got it in standard form, but with both an ellipse and a hyperbola, I have to have it set equal to 1 over here. So I divide each side by 9, divide everything by 9, and so I get x plus 3 squared over 9, or 3 squared. Okay? And if you think of this, see, y minus 1 squared, see, normally we don't want to have a number up here either. So in addition to dividing by 9, I also went ahead and divided by a 4 to get rid of that number there. So my denominator here is actually now 9/4 equals 1. So I divided by 9 to get a 1 over here, and then I divided by a 4 to get rid of that 4 right there. All right, so now I'm ready to answer all the questions. So I start off with the center is at negative 3, positive 1. Let's see. Right. Okay. All right, so the center, you take the opposite of the signs in here, so negative 3, positive 1. Okay. Now to find the foci, that's going to be, you use little c squared equals a squared minus b squared. And so c squared is going to be, okay, so which of these is bigger? Well, 9 is bigger than 9/4. So 9 minus 9/4. So c squared would be, let's see, 36/4 minus 9/4. So c squared is, it's at 27/4. So then c would be plus or minus the square root of 27/4. So let's see, that would be, well, the 27 is 9 times 3. So the square root of 9 is going to be 3. So that'll be 3 radical 3 in the numerator. Square root of 4 is 2. So that will come out there. All right, so then once we have the c, that's the distance to the foci. So what we're going to do is add that to the center. Let's see, since 9 is bigger, it's a horizontal ellipse, so I'm going to add it to the x value. Okay, so negative 3, so it's going to be negative 3 plus or minus 3 radical 3 over 2, comma, 1. So those are the foci. All right, to find the vertices, again, the number underneath the x is bigger, so we go to the left and right 3 from the center. So the vertices are going to be -3 plus or minus 3, comma 1. And then if we simplify that, we'll get 0, 1, and -3 minus 3 would be -6, 1. Now, if you're more of a visual person and you get lost in this, it wouldn't hurt to graph it and then count over left and right 3. Then you might be able to find it easier that way. Okay, so let's see, center, foci, vertices. All right. Any questions on that?
How would you know to put the center by the x value?
Great question. It's because the number underneath the x is bigger, so that means it's a horizontal ellipse. So you'd go left and right. Whereas if the number underneath the y is bigger, then you'd go up and down, and you'd add it to the y value. Does that make sense? All right. Other questions on this particular problem? All right. Next question then.
Can you do number 43 on the practice final?
You bet. 43. Okay. All right. So here we're simplifying. Okay. We're simplifying this. So there's a couple of things that will help us. All right. Now, when you're simplifying, it really is going to help if you have the back flap of your book open to look up different identities. The first one is the sign of -x. So there, if I look at the even-odd identities, okay, so I'm looking at the even-odd identities, or if you know them, that the sign of -x is equal to the negative sign of x, okay? So we can simplify that. Now, the second one is a period. Let's see. No, that's a u minus v. Let's see. Do I have that one? Okay, so the cofunction identity. So I'm using a cofunction identity for the denominator, which says that's at the second column in the back flap. That's where I'm looking, and so it says the sine of pi halves minus x is equal to cosine x. Okay, so now using those two identities here, I've replaced sine -x with negative sine x, and the sine of pi halves minus x, I've replaced that with cosine x. Okay, all right, next I'm going to use the cotangent identity, which says that the cotangent is cosine over the sine. And so now I look and see what I have left. Well, the sines are going to cancel. The cosines are going to cancel. And so all I'm left with here is -1. Okay. All right. Other questions on any questions on this problem? All right. How about next question then?
So I don't know what number it is. It's on like page 9 of the review. It says, verify the identity.
Okay. That might be one of the bonuses, but no, it's not. So I think it's on page 9.
It's before those ones.
Oh,
So there's no number for it, but
oh, really?
yeah. It's like after number 46, so I guess but there's like a bunch of bullet points and then it's this one.
Okay. So it's after. Oh, is it? It's not
Yeah.
50.
It is 50, yeah.
Okay.
It's just not numbered on my paper.
Oh, you know what? It's because see, that's my fault. Is because I posted that last year before I knew about saving as a PDF. Because the PDF saves it exactly how I want. But see, what it is the fact that it's the margins might be messed up in the numbers. It's because Holbrook High School upgraded their Word, and which dropped the font that I use. So anyway, but so now I know better, and so what I'll do is after this afternoon, I'll update it and I'll resave it as a PDF if that matters. I guess it doesn't really matter because you've already printed it out, but. Okay, so let's look at this one here. Let's see if we've got number 50. Okay, so it says use formulas to verify the identity. So here we have the sine of x minus 3/2 equals cosine of x. So to verify identities, remember you work with the more complicated side. And you've got to work at it until you get what's on the other side. All right, so with this one, we're actually going to use the sine of u minus v formula. Okay, so all of these formulas are in the back of the book. Now, I used to, even when I didn't give open book finals, I used to give formula sheets. And so I'm not really expecting you to ever memorize these formulas, but you do need to know how to use them. So this is good practice for brushing up on how to do it. So here, basically, everywhere you have a u in the formula, you're going to replace it with x, and everywhere you have a v, you're going to replace it with 3/2. So the sine of u minus v is going to become the sine of x times the cosine of 3/2 minus the cosine of x times the sine of 3/2. All right, then you Yes, go ahead.
Do you not put the negative in? Or negative 3 pi?
Oh, no, see, that negative goes with the formula. So it's u minus v, so it's right there in the formula. But so yeah, you don't. That's an excellent question. You don't include the negative with the angle. It's included with the u minus v formula. Okay. All right. Good. Okay, so now you go and either from memory, from your unit circle or whatever, and you definitely want to have the unit circle ready when you take the final. Have a copy of it there in front of you. So the cosine of 3 pi halves, okay, so 3 pi halves is done at 270. The cosine is 0. The sine of 3 pi halves, that's the y value down there, and that's at -1. So you plug in 0 here and -1 here. Well, then that means this term is going to go away, and so you have negative cosine times -1 is positive cosine x, which is what we wanted. And so that's it. All right. Any questions on this problem? All right, next question.
Could you do number 32,
Sure.
please?
I'd be happy to. Number 32. Okay, so number 32 says find the exact value of each of the following. Now, when the problem says find the exact value, then typically that means you're not going to use a calculator. So you're either going to use the unit circle or special triangles or something like this. So this is the inverse cosine of the square root of 2 over 2. All right, so what angle, so remember for the inverse trig functions, the angle is going to be the inverse trig function. So the inverse cosine is asking what angle has a cosine of radical 2 over 2.
So it's 45.
So it would be 45 degrees, and what if all the answers are in radians? Then what's the answer in radians?
Better.
Pi over 4.
Pi over 4. Okay. All right. So let's do number 33 just for fun. So the arc secant, the angle that has a secant of negative 1. Well, arc secant, that doesn't really like show up on your unit circle. But the secant is the reciprocal of what?
Cosine.
The cosine. So this is saying it's the arc, this is the same thing as the arc cosine of, well, the reciprocal of that would be 1 over negative 1, which is just negative 1. So this is the same thing as the arc cosine of negative 1. All right, so then what angle has, whoa. Let me grab that. There we go. Put that there. So what angle has a cosine of negative 1?
$180.
180 degrees, or, and what would that be in radians?
Pi.
Or pi radians. Good. Okay? So you just have to look and see, would the answers be given in degrees or radians there? I could do it either way. Okay?
Can't you just plug those into the calculator too?
Well, okay, so let's say all the answers to the first one, let's say it's all in radians, okay? And pi force is the answer that I'm looking for, okay? Probably, I mean, you're going to have your calculator set up pretty well for it to give you pi force as an answer. Typically, it's not going to do that. Whereas just looking at the unit circle, you can just see, oh, that's going to be pi force, okay? This one, where the answer is 180, or again, if it's in degrees, because these end up being exact values, you probably could get it in degrees with the calculator, but the radians probably not. Okay.
Can you show us on the calculator real quick how to do the arc, like secant and stuff like that?
Like this, how to put that in
Yeah.
the calculator? Okay. So, all right. Okay. So first of all, let's do the first one here. So inverse cosine of radical 2 over 2. See, you've got to look and see what mode that you're in. So let's say we're in radian mode here. And so if you did inverse cosine, so that's second cosine of square root of 2, square root of 2. Oops, wait, no. Square root of 2, get out of the square root, divided by 2. And if you press enter, see, it's not going to give you the exact value. The calculator won't. So that's why usually for these that say use the exact value, I don't use the calculator. I'll just go to the unit circle. Okay. Now, if whoops. So, but for the second one, see, arc secant, the calculator only does inverse sine, cosine, and tangent. So for arc secant, you would have to mentally change it to arc cosine of the reciprocal of this. It just happens to be the same thing, but So then you could put in your calculator arc cosine of -1. So second, well, let's, so if I do second cosine of -1, see, that's going to be in radians. So if all the answers are in degrees, then just change your mode to degree mode. Okay, and then if I press enter, then now that I'm in degrees, it'll give me 180 degrees for that one.
Actually, the 3.14 is pi though, so you could figure that one out.
You could probably figure it out, sure. You could, but see the, but that one might be a little harder. 0.785. I mean, you could probably figure it out. But now okay, but here's the deal. Because I'm asking for the exact value, I mean, you don't have to really worry about this because this test is multiple choice, true, false. But let's say if it was a fill in the blank and you gave me 3.14, it would be marked wrong because that's not the exact value. The exact value is pi. Okay.
I actually think I just figured out a way you can do it. So if you take the 0.7853 and divide it by pi, it gives you 0.25, which is 1/4. So it's pi fourths.
Yep, you can do it that way too. Good. Good. All right. So yeah, if you're in radians, and that would work if your answer is pi thirds or pi six, you just multiply by pi. Okay. All right. Any other questions on this? All right. Next question.
Can you do 63 through 69 on the practice final?
Okay. Okay, so this is a vector one here. All right, so it says if point P is 0, 5, and point Q is -3, 2, R is -4, 7, and S is -7, 4, write V equals vector PQ and W equals vector RS. Okay, so write V in component form. So that's PQ. So in component form, you do the terminal point minus the initial. So the order matters. Otherwise, you'll get the signs wrong. So it has to be the terminal minus the initial. So it's Q minus P. So -3 minus 0 and 2 minus 5. So that's going to give you -3, -3 is your vector in component form. All right, any questions on that one? Okay. What is the magnitude of V? Well, so here's V. To do the magnitude, once we're in component form, you just square each component, add them up, and take the square root. So that's the magnitude of V. All right, any questions on that? All right, what is the directional angle for V? All right, to get the directional angle, that's where you do, to get the reference angle, theta prime, it's inverse tangent of B over A. Now, when you see this little prime on the angle, what that hopefully reminds you is that you have to make sure that that angle is in the right quadrant when we're done. Okay? All right, so what we're going to do, so we do the inverse tangent of -3 divided by -3. And so that's the same thing as the inverse tangent of 1. And maybe you know that the angle that has a tangent of 1 is 45 degrees, or pi/4. So now, is 45 degrees, though, in the same quadrant as -3, -3? And the answer is no. -3, -3 is down here in quadrant 3. So the reference angle is 45 degrees from the x-axis. So then what we want to know is, what is this red angle all the way across and then 45 more degrees? How much would that be?
225.
225. So that would be the angle. Okay. All right. Any questions on that? Okay, let's keep going. So write the trig form of vector v. All right, so the trig form, you've got to know the magnitude, which we already calculated. Okay, and we need to know the angle, which we've already calculated. Okay, so then the trig form is the magnitude times the cosine of the angle, comma, the magnitude times the sine of the angle. So that would be 3 radical 2 cosine 225, 3 radical 2 sine 225. Now, if it's usually, I mean, that's in component form. Well, this is the better answer here. Okay. Any questions on that? Okay, let's go. I think it was it through 69? Okay. Yes?
Yeah.
Okay. All right, so write the unit vector u in the direction of v. So to write the unit vector, then you take your vector in component form and then divide by the magnitude. And so the magnitude we already calculated, the component form we already calculated. And so we're going to divide -3, -3 by 3 radical 2. And there you can cancel the 3's. And so you'll either have your answer written like this, or if you rationalize the denominators, then you might see it written like that. But these two are equivalent answers. So you just, to do it as a unit vector, you do the component form divided by the magnitude. All right, any questions on this one? All right, write u as a linear combination. Well, there you just take your last answer, your unit vector, and you take off your component form special brackets, and then you just slap an I after the first one number and a J after the second one. And then it becomes a linear combination of unit vectors. So any questions on this one? All right, we might, go ahead.
You skipped 68.
Did I? Okay.
Yeah.
All right. Maybe it was too hard. Let's see if I've got it down here. There we go. Show that U is a unit vector. So, so to show that U is a unit vector, you take the magnitude of your answer and see if it's 1. Because if it's equal to 1. So the magnitude, you take your unit vector and you square each component. So negative radical 2 over 2 squared plus negative radical 2 over 2 squared. So when you square the radical 2, you'll get 2. The negative goes away. 2 squared is 4. So you get 2/4 plus 2/4 is 4/4, which is 1, and then the square root of 1 is 1. So now, you know, it's kind of hard for me to ask you a question like that on the final, you know, show this or prove this, because it's multiple choice and true false. But I could say true or false, blah, 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 is a unit vector. And then you'd have to, you know, work it out. Okay.
So is this practice exam an accurate representation of what our final is going to be, or is it just
Well,
like
as far as the content, yes, but not how the problems are phrased, because the questions are multiple choice, true, false, that kind. So, but yeah, I could ask this question, only make it into a multiple choice question or true, false question. Okay. All right. Well, we're down to the last couple of minutes, so. So I'm going to be doing a review for my afternoon trig class. And so then after that, then there might be some extra slides on this that, you know, where I've got problems worked out. And so I will post that this afternoon. And so you can look at, you know, more problems worked out if you'd like. I would highly recommend that you going through and studying with someone. You know, and just kind of comparing answers and so on. Or if you have questions, don't hesitate to email me this week, or, you know, even though we're in the middle of the final exam time, if you had a concern about a question, don't hesitate to shoot me an email. But having said that, I'm not going to see you guys anymore. This is it. It's our last minute. And I do want to tell you, I've really enjoyed this class. Really, this has been a great semester for me, but I've really looked forward to working with you guys, and I really appreciate all the hard work, and I'm hopeful that everyone will get the college credit so that you can get a reward for all your hard work. So that's my hope for the final. But anyway, I just want to thank you again for working hard, and keep working hard this week. And anyway, and I hope to see you next year if you're not a senior in Calc 1 next fall. So anyway, good luck with that, and sayonara. Peace out. We'll see you. Good luck, you guys.
see you later, Mr. Strong.
Bye.
Thank you.
Have a good day.
Thank you.